Here we go. Basic solving for x question. 13 says, which value of x satisfies the equation 5/6 times 3/8 minus x is equal to 16? Okay, so essentially what we're going to do is we're going to take that 5/6 and distribute it into the parentheses. And if you don't know how to multiply fractions by now by hand, you really should. Of course, you can plug it into your calculator, but really, multiplying fractions is not that bad. You basically just multiply across this. So 5 times 3 is 15. 6 times 8 is 48. You can even reduce this to 5/16 just because you could take out a common factor of 3. Okay? So, let's go ahead and solve it. So when we distribute that in, we get 5/16 minus 5/6 x is equal to 16. It's going to get a little messy here, folks, so bear with me. We're going to subtract the 5/16 on both sides. Okay? We get negative 5/6x is equal to, now what is 16 minus 5/16? Again, I use the TI Inspire, pretty powerful calculator. 16 minus 5/16. Get an answer of 251/16. And now what we're going to do is we're just going to multiply by the reciprocal of that fraction to get rid of it. So we multiply by negative 6/5. Multiply by negative 6/5. Cancel those out, and we get x is equal to, let's go to multiply, control division, negative 6/5. We get negative 753/40. Convert that to a decimal, so go to menu, number, approximate, nope, I'm sorry, convert to decimal, and we get negative 18.825. Negative 18.825 is that answer up here somewhere, and it is. Your answer is choice 2. Moving on to number 14. If a population of 100 cells triples every hour, which function represents P of t, the population after t hours? So it says here triples. When I hear the word triple, I think of multiplication. So get rid of any answer that shows a line, because the graph has to look something like this. Really, really fast growth. It's not growing at a constant rate like a line. It's got to be exponential growth. So choices 3 and 4 show lines. This shows a slope of 3. This shows a slope of 100. Those make absolutely no sense. Get rid of them. Choices 1 and 2, on the other hand, those show exponential growth. Absolutely. Now, it says here, a population of 100 cells triples. So, the 100 that you see here, that is called the initial amount. The initial amount is the amount that you start with. So the function or the equation that you should really come to a conclusion for, it's P of t equals the initial, which is 100 cells, times the 3 raised to the t power, where this is the starting or the initial, and this is the tripling of those cells. Okay, so your answer for this one is going to be choice 2 for that question. All right, number 15. A sequence of blocks is shown in the diagram below. This sequence can be defined by the recursive function a sub 1 equals 1 and a sub n equals a sub n minus 1 plus n. Assume that the pattern continues. How many blocks will there be when n is equal to 7? Okay, you need to know what recursive means, okay? I mean, you really don't need to get this right, but it's nice to know what recursion is. Recursion means that you're given the first term, and then you're given the general equation to generate the following terms, okay? So this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4, okay? So this clearly has 1 block, this has 3 blocks, this has 3, 4, 5, 6 blocks, this has 3, 4, 5, 6, 7, 8, 9, this has 10 blocks. So, folks, there is no pattern here, okay? Well, actually, there kind of is. You know, you could see that you're adding by 2, then you're adding by 3, then you're adding by 4. Unfortunately, I wouldn't bet money on that it's plus 5, plus 6, plus 7. It could be. Chances are it is, because I'm telling you it is. But you really should go ahead and, you know, do the math. So if I want to find a sub 5, for example, a sub 5, we're going to take this formula here and we're going to apply it. So this is a sub, okay, so where you see an n, which is that little subscript there, n minus 1. So we want to find the fifth term, right? So we plug in the number 5 minus 1 plus n, which is the number 5. We're trying to find the fifth term because we're finding a sub 5. So what we get here is we get a sub 5 is equal to a sub 4. 5 minus 1 is 4 plus 5. Well, what is a sub 4? It's 10 because those are the amount of blocks right there. So we get 10 plus 5, your answer is 15. So that is a sub 5. So we know that a sub 5 is equal to 15. Let's go ahead and solve for a sub 6. Okay. A sub 6. A sub 6 is equal to a sub 6 minus 1 plus 6. We get a sub 5 plus 6. Well, we have a sub 5. A sub 5 is now 15. So that's 15 plus 6. We get 21. So a sub 6 is equal to 21. Okay. Now we're finding the seventh term. The seventh term. So we get a sub 7 is equal to a sub 7 minus 1 plus 7. That gives us a sub 6 plus 7. That gives us, well, a sub 6 we know is 21. Add that 7, we get the number 28. Your answer is choice 3 for that question. And yes, there is a pattern. Plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. You could have done it that way too. I wouldn't do that for the future though. Number 16. Mario's $15,000 car depreciates in the value at a rate of 19% per year. The value v after t years can be modeled by the function v equals 15,000 times 0.81 raised to the t power, which function is equivalent to the original function. So they're really, really, really testing your knowledge on whether or not you understand exponents. Do you see here that the only manipulation that they're making in these answers, all of these answers, is the inside piece is no longer 0.81 and the exponents have changed, right? The exponents have changed here, 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 and here. So essentially what they're telling you is take that exponent and raise 0.9 to that power. So let me be more specific here. Choice one, what they want you to do is take 0.9 and raise it to the 9th power, which raises to the t power. Okay, let's go with your power to power rule. You could actually separate these numbers and apply it to one of them. So the 9 can be applied to the 0.9 and just raise it. So if you take 0.9 and raise it to the 9th, that gives you 0.387 approximately. That is not equal to 0.81. So that's not true. Okay, let's take a look at choice 2. Choice 2, what we're doing is we're taking 0.9, squaring it, then raising it to the t power. So 0.9, raising it to the 2nd power. Come on, 0.9 raised to the 2nd. We get, oh man, 0.81. We got it. Your answer is choice 2. As you can see, all they did is they just took that 2, the square, and they just put it on the outside, and that's the exact same function. The t is still there. It's just that the 2 is outside of this one, and it's inside of this one. Okay? That's how you do number 16. 17. The highest possible grade for a book report is 100. The teacher deducts 10 points for each day the report is late. Which kind of function describes the situation? Well, if you have a book report due, and you get 100, or it's out of 100 points on the first day it's due, you could get 100 points. But then all of a sudden it decreases by 10. So it keeps on going down by 10 points per day. So the first day of lateness it's minus 10. The second day of lateness it's an additional 10. The third day of lateness it's an additional 10, and it keeps going down. So really this is a linear function. Because on the due date, right? On the due date, if you need to see this a little bit further, the due date is 100. Oh, I just put a dollar sign. My apologies. It's 100 points. Okay. Then the first day, it is late. The first day of lateness, it drops down to 90 points. Then the second day of lateness, it drops to 80 points. And it keeps on going down. So we're decreasing by 10. It's linear because it has a slope of -10. That's it. Your answer is choice 1. Number 18. Okay. Number 8. Ooh, this looks interesting. Number 18 says the function h of x. Function h of x, which is graphed below, and the function g of x is this. So they gave that to you. Which statement about these functions are true? Okay. I think this was one of the harder multiple choice questions on this test. So let's go ahead and figure this out. So this is h of x. Let's go ahead and graph g of x. Let's just do it. Go and graph g of x on your calculator. So we graph g of x. This is 2 absolute value of x plus 4 minus 3. So we get that. Control T. We get these table of values. So I'm actually going to save a little bit of time. I'm not going to copy them over. I'm actually just going to go ahead and graph it for you. You could copy those yourself. So this is down 1, 2, 3, 4. Down 1, 2, 3, 4, 5. And then up 2 to the right 1. So what I'm graphing here, folks, this is g of x. Okay? This is g of x right here. So we got that here, and we got that over here. So we got g of x, okay? Now, let's go ahead and figure out what they're saying here. Number 1 says g of x has a lower minimum value than h of x. In other words, it has a lower turning point, okay? Lower turning point. Is that true for g of x? Yes, it is. This is obviously lower than that one. So this is true. For all values of x, h of x, which is the black one, is less than g of x. Really? Really? This is higher. This is lower. For every single for every value of x. For every value of x, the pink is less than the green. Because if you extend these forever in this direction, it is not going to get greater than that, okay? So that's incorrect. For any value of x, g of x is not equal to h of x. Does this intersect anywhere on the graph? No. So that is true. There's no value of x where these two things are equal. So your answer is choice 2. And if you're wondering why there's no values of x, it's because these have the same slopes. And you're going to learn this in geometry if you didn't learn it already. If you have two lines that have the same slope, they never intersect if they have different y-intercepts. Okay? So that's why choice 2 is the answer. Moving on to number 19. The zeros of the function f of x equals 2x to the third plus 12x squared minus 10x squared are what? So, we need to do some cleaning up, people. First of all, we need to put these in descending power order. So this is 2x to the third minus 10x squared plus 12x. Okay? Now what we're going to do is we're going to apply our factoring method. Take out the greatest common factor. Then find the difference of two perfect squares. Then apply the trinomial method. Okay? So the GCF in this case, obviously it's a 2 because 2 could go into 2, 10, and 12. And there's an x. Okay? So f of x just becomes 2, take out an x, you're left with x squared minus 5x plus 6. Okay? So from here, what we're going to do is we are going to find this in here. This could factor by using the AM method. What adds to -5 and multiplies to give you 6. So we get f of x is equal to 2x times x minus 6. Actually, no, I'm sorry. X minus 3, x minus 2. X minus 3, x minus 2. Set that equal to 0. Now we just solve for x. Draw your t-bar. We get 2x equals 0. Divide by 2 on both sides. And we get x equals 0. X minus 3 equals 0. We add the 3 on both sides. X is equal to positive 3. and x minus 2 equals 0. We add that 2 on both sides, and we get x is equal to positive 2. And that's it. So we get 0, 3, and 2. Your answer is choice 3. Okay? Do not forget about that x over there, because many of you probably went for that answer right there, but just keep in mind that 2x has to be set equal to 0 as well. Okay, moving on to number 20. How many of the equations listed below represent the line passing through the points 2, 3, and 4, negative 7? So here's the thing. You could actually plug in these points for x and y. So plug this in for x and y, plug this in for x and y into all of these and see if they equal and they have the same outputs. That takes a while, a long time. I'm going to show you a different, actually, no, I need to show you both ways. I'm going to show you on the graphing calculator, and I'm going to show you how to do it algebraically. Just because you might not have the TI Inspire, which is another reason why you should get it, you might have the TI 84 or 83 or something else. So, what I'm going to do is I'm going to take the 2, 3, I'm going to plug it into the first equation. So, we get 5 times 2, because 2 substitutes in for x, plus 3. Does that equal 13? Well, 5 times 2 is 10, plus 3 is 13. 13 does equal 13. That checks out. But we need to make sure that the 4, negative 7 work as well, because it says passing through the points 2, 3, and 4, negative 7. They need to work for both. So let's go ahead and find out if 4, negative 7 works. So 5 times 4 minus 7 equals 13. 20 minus 7 equals 13. Does 13 equal 13? Yes, it does. So that works. So this so far is a good line. That is good. That's a good thing. Okay? So we found out that the first equation works. Now we're going to go ahead and find out if the other lines work. So same process again. Plug it in. So we get y. Okay, so y is now 3. So we get 3 plus 7 equals negative 5 times x, which is 2, minus 4. So we get 10 equals negative 5 times 2 minus 4 is a negative 2. We get 10 equals 10. That checks out. Now we need to check the purple one. So we get negative 7 plus 7. That equals negative 5 times 4 minus 4. Negative 7 plus 7 is 0. Does that equal negative 5 times 0? Well, negative 5 times 0 is just 0. Does 0 equal 0? Yes, it does. So this line also works. So that's good. That's a good line. Okay. You see how long this takes? This is annoying. All right, let's do it again for the third line. Okay. So we get 3 equals negative 5 times 2 plus 13. 3 equals negative 10 plus 13. Negative 10 plus 13 is 3. Does 3 equal 3? Yes, it does. Let's check the purple one. We get negative 7 equals negative 5 times 4 plus 13. Negative 7 equals negative 5 times 4 is equal to negative 20 plus 13. Negative 20 plus 13 is negative 7. Does negative 7 equal negative 7? Yes, it does. So that is a good line. So far 3 of them work. So we can get rid of choices 1 and 2. Let's go ahead and see if the last equation works. Let's do it. Here we go. So, for the red one, we get 3 minus 7 equals 5. Fix that. 5 times x minus, should have replaced that x, stupid me, 2 minus 4. 3 minus 7 is negative 4. That is equal to 5 times negative 2. Negative 4 does not equal negative 10. So therefore, this blows up. Doesn't work. Your answer is choice 3. There are 3 lines that satisfy this condition. I'm going to show you on the graphing calculator. So if you actually go to menu, go to graph entry edit and click on relation, what this calculator could do, which is so freaking cool, is you could just type in the exact equations that they show on the Regents exam. So the graph stat line, y plus 7 is equal to negative 5 times x minus 4. To get to the next one, you just press the down arrow. Just to, oh, look at that. Look at that. So it looks like just by looking at the graph, all of these are the same line. Or the first three, I should say. Look at that. They're all overlapping each other. Except the last one. Y minus 7 is equal to 5 times x minus 4. Look at that. You see? Look at that. These three lines, there's actually three under there because it overlaps with the different colors. The pink line is obviously not even the same as this one, so that is why that one doesn't work. So your answer is choice 3. Moving on to number 21. The Ebola virus has an infection rate of 11% per day as compared to the SARS virus, which has a rate of 4% per day. Ugh. I know what Ebola is. I don't know what SARS virus is. If there were 1 case of Ebola and 30 cases of SARS initially reported by authorities, and cases were reported each day, which statement is true? So here's the thing. You need to set up some equations to get this answer right. So let's figure out what the equations are. But you need to understand that it is increasing at a percentage rate. So by now, please, it's on every algebra regions. Make sure that you know the formula A of t equals the principal times 1 plus or minus the rate raised to the t power. Basically, you take the initial, you take 1 plus or minus the rate of increase or decrease, and you raise it to the amount of days or time, hours, whatever it is. So look at this. Ebola has an infection rate of 11% per day, and there are 30 cases of Ebola. The SARS virus has a rate of 4% each day, which initially... Oh, I'm sorry, no. There's 1 case of Ebola. 1 case, and there's 30 cases of the SARS virus. Okay. Which statement's true? So let's go ahead and set up our equations. So I'm going to call this E of t for Ebola. E of t is equal to the principal, which is the number 1, times 1 plus 0.11 raised to the t power. Why is it plus? Because you're getting more people sick. It's a positive rate of increase. Then, the SARS virus, so S of t, is equal to the initial amount of 30 people, got it? So it's 1 plus 0.04. Remember to convert those percentages, raised to the t power. We don't know the t because it's saying at day 10. So obviously we're looking at when t is equal to 10 days. So let's go ahead and graph these functions and let's see what happens. Okay, 1 times 1 plus 0.11. Now remember, since you're in the calculator, you got to raise it to the x power because your calculator is in terms of x, or the function is in terms of x. And we get 30 times 1.04 raised to the x power. So obviously you can't see the red one. I'm actually going to make this like 100 cases. And I'm going to make this 0 because there's nothing over there. I'm going to make this x value, I'm going to make that 100 as well. Make it, actually no, I'm sorry. Yeah, make it 100 days. Okay. Look at this, folks. It looks like that the SARS virus, for however many days this section is, that the SARS virus is more infectious. Then all of a sudden the Ebola just takes off. There's the intersection point over there. It just takes off, and the Ebola becomes very, very widespread. So back to the question. At day 10 and day 53, there are more Ebola cases. Okay, so they're telling me 2 different days, the 10th day and the 53rd day. So let me go ahead and fix this up a little bit. I'm actually going to make this little box here 10. I'm still going to make that like maybe 150. I'm going to make this over here. I'm going to make that 53 days. I'm going to make this 0 down here. Okay. I'm going to increase this. I'm going to make that 300. Okay, look at this. Here we go. This intersection point. So if you click on menu, analyze graph intersection, click. This is on the 52nd day. On the 52nd day, the Ebola virus takes over. No, I'm sorry. Yeah, the Ebola virus takes over the SARS virus. So, let's take a look here. At day 10 and day 50, there are more Ebola cases. Absolutely not. That is only true for day 53. there's more Ebola cases on day 53, but day 10, it's down here, there's more SARS viruses. So that's not true. At day 10 and day 53, there are more SARS viruses. As I just said, no, the SARS virus has more cases at day 10, but less cases at day 53. Okay, so that is not true. At day 10, there are more SARS cases, but at day 53, there are more Ebola cases. Oh, yeah. Absolutely true. There's more SARS viruses at day 10, and there are more Ebola viruses at day 53. So that is true. Choice 4 is just the reverse of choice 3. Makes no sense. All right. Choice 3 is your answer. Moving on to number 22. The results of a linear regression are shown below. Which phrase best describes the relationship between x and y? So basically, folks, what you're looking at here is this. It says ax plus b. This is really just mx plus b, but they substituted in for a. Look at this. A is negative. This indicates to you negative slope. So obviously, this is a negative correlation, so it can't be positive. You got to get rid of choices 2 and 4. Then let's take a look at the correlation coefficient. Remember what this value does. The correlation coefficient tells you the strength of the relationship. Okay? And remember that the correlation coefficient is in between the numbers -1 and 1. If it's really, really close to -1 or it's really, really close to 1, it's a strong correlation. If it's closer to 0, it's not. As you can see, that is fairly close. This number is fairly close to -1. I mean, if you want to, you could round it upwards. This is -0.9, which is fairly close to -1. So therefore, it is a strong negative correlation. Your answer is choice 1 for that question. Okay, 23 was the hardest question, in my opinion, on the multiple choice section of this exam. Let's go through it slowly. Abigail's and Gina's ages are consecutive integers. Consecutive integers means one follows after the other. So, 1, 2, 3, 4, 5. Those are consecutive. They go right after the other in order. Abigail is younger than Gina, and Gina's age is represented by x. If the difference of the square of Gina's age is 8 times Abigail's age... No, I'm sorry. If the difference of the square of Gina's age and 8 times Abigail's age is 17, which equation could be used to find Gina's age? Oh, man, this is a hard question. Okay, let's take it slow here. Gina is represented by x, so I'm going to let x equal Gina's age. It all comes down to Abigail's age. Abigail's age is going to be tough. So, actually, let's do this. Oh, wait a minute. Abigail and Gina's ages are consecutive integers. So if Abigail is younger than Gina, that means I'm going to let x minus 1 equals Abigail's age. And the reason why is that they're consecutive. All right, so they are certainly consecutive. So if this is x, this has to be x minus 1 because Abigail's younger. Consecutive, remember, means one after the other. All right, so we got this information. Now all of a sudden they throw in this garbage. If the difference of the square of Gina's age and 8 times Abigail's age is 17. Okay, this is ridiculous. So, difference. Difference means subtract. Square means raised to the second power. 8 times. Multiply by 8. The word is in math means the equal sign. And it has to equal 17. So, let's see here. So, if the difference, so we're definitely subtracting, but it depends on which one goes first. If the difference of the square of Gina's age, the difference of the square of Gina's age, so Gina's age is x, we're squaring Gina's age. And we're subtracting because it says difference, and the difference of 8 times, with the multiplication, Abigail's age is 17. Ladies and gentlemen, that is the equation to solve for their ages. Your answer is choice 4 for that question. That was a tricky one. A lot of words. Make sure that you know these code words in mathematics. All right, so your answer is choice 4. Last question of this video. Which system of equations does not have the same solution as the system below? So basically, this is a very common question. All they're doing to you here is that they're multiplying these numbers by some number, by a scalar. So in this case, the top equation is 4x plus 3y equals 10. You're looking and comparing these here. You're looking at all of these. Okay? So let's go ahead and figure this out. 4x plus 3y equals 10. Let's take a look at choice 1. All of a sudden, that's a negative 12. So you're thinking to yourself, 4 times what number gives you negative 12? Well, 4 times negative 3 gives you a negative 12. So what your job is to take that negative 3 and distribute it into all the numbers, and let's see if it equals that. Well, negative 3 times 4 gives you negative 12. Good. Negative 3 times 3 gives you negative 9. Good. Negative 3 times 10 gives you negative 30. Good. So far, that's a good answer. Let's take a look at the other one. So in this case, 4 times what gives you positive 20? Well, 4 times 5 gives you 20. So take the 5 and multiply it. 5 times 4 gives you 20. Good. 5 times 3 gives you 15. Good. 5 times 10 gives you 50. Good. So that's a good answer as well so far. Okay. Let's take a look at choice 3. 4 times what gives you 24? Well, 4 times 6 gives you 24. So let's distribute that 6. 6 times 4 gives you 24. Good. 6 times 3 gives you 18. Good. 6 times 10 gives you 60. Good. So all those are correct. Great. Let's try this one. 4 times what gives you 40? Well, 4 times 10 gives you 40. Distribute that 10. 10 times 4 gives you 40. Good. 10 times 3 gives you 30. Good. 10 times 10 gives you 100. Good. So that works as well. Oh my God. We need to use the second equation. One of the second equations is wrong. So we got to get rid of this. Now our focus is this right there. We got to focus on these here. Annoying. So let's do it right now. So here we go. So negative 6 times what gives you positive 12? Well, negative 6 times a negative 2 gives you a positive 12. 2 negatives give you a positive answer. So we distribute. Negative 2 times negative 6 gives you positive 12. Good. Negative 2 times negative 5 gives you positive 10. Good. Negative 2 times negative 16 gives you positive 32. Good. Choice 1 is incorrect. We're trying to find the one that does not have the same solution. Okay. Let's do it again. Negative 6 times what gives you negative 18? Well, positive 3. 3 times negative 6 gives you negative 18. So we distribute. 3 times negative 6 gives you negative 18. Good. 3 times negative 5 gives you negative 15. Good. 3 times negative 16 gives you negative 48. Good. That answer is incorrect. Let's keep going. Negative 6 times negative 6 times what gives you negative 24? That's just positive 4. Distribute that 4. 4 times negative 6 gives you negative 24. Good. 4 times negative 5 gives you negative 20. Good. 4 times negative 16 gives you negative 64. Yes, that's good. Oh, dear Lord. All right, so we're done with that one. Let's make sure choice 4 is incorrect. Negative 6 times what gives you positive 36? Well, that's just negative 6. Okay. Negative 6 times negative 6 gives you 36. Good. Negative 6 times negative 5 gives you 30. Good. Negative 6 times negative 16. Uh-oh. Negative 96? Huh? A negative and a negative should give you a positive answer. A negative 6 times a negative 16 should be positive 96. They decided to make that negative on you. So that's why your answer is choice 4 for that question. Was it a pain in the neck? Yeah, I think it is. I think that's a pain in the neck, but it's doable. All right, that's the end of this video. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I will greatly appreciate it, and you will have my undying gratitude. And make sure that you visit my website at www.nysmathregionsprep.com for more topics or more review in Algebra 1. And in your future, you're going to see Geometry and Algebra 2, and you might see a few more math courses in your high school future. And I hope to see you soon.